Okay, so now we're going to switch gears now that we have a basic understanding of this concept of inflation, and we're going to start identifying several different concepts that we can use to determine both the future value of money and the present value of money. And something important to mention here is that we're going to be using some tables from the appendix in your textbook in order to run a lot of these calculations. So if you have the textbook, I would open it up to page 454. That's where these appendices start, and we're going to be using A1 through A4. And I've given you just a little overview here of the 4 different tables we're going to be using. So A1 is going to help us calculate future value of a dollar. A2 is going to help us calculate future value of an annuity. A3 is going to help us calculate present value of a dollar, and A4 is going to help us calculate present value of an annuity. So again, make sure you have the textbook handy. These are tables that are going to be really useful in saving us time in terms of calculating a lot of these things. We're going to examine what it looks like to do them long form, but the reality is that these tables exist as a shorthand, right, for us to save a lot of time. Because in the real world, we just wouldn't have the time to run these formulas by hand. So we're going to rely on these tables to help us get to the same answer ultimately, but save some time in the process. So make sure you have those tables in front of you, and I'm also going to show you some examples of how to use them through the next few video series. So this first one is going to focus on A1 and A2, so the future value of a dollar and the future value of an annuity. Okay, so let's start with the future value of a dollar. So when we think about a future value of money, we're not only looking at potential loss of spending power over time, which is what we did when we examined inflation in the last video, but we can also account for gains in regard to interest payouts, right? So we calculate future value of money by looking at the interest rate applied over a period of time. So to make it individual to you, think about any money that you've ever saved, right? If you had a savings account as a child, maybe you put some money in there over time. You probably earned some interest on that money because the bank was able to use it and invest it. So that's really what we're referring to here when we think about future value of a dollar. We want to account for the interest gained on that investment as it's sitting in the bank for a particular period of time. Excuse me. So a quick example here for calculating future value of a dollar using interest. A sport organization invests $100 in a savings bond that pays 5% annually. The value of that investment after 1 year we can find by using this formula. So we want to take the original investment plus the interest gained. That gives us our future value of a dollar, right? Pretty straightforward, right? In this case, we know the original investment was $100. We know the interest on that savings bond is 5%. So all we have to do is take 5% times 100. We know that in that year's time, that investment is gaining $5, right? So we add those together. We know that in a year, that savings bond is going to be worth $105, right? Pretty straightforward, right? Now, what we've just done or looked at here in this example is basically what we call simple interest. So simple interest only accounts for principal or the original investment itself. It does not take into account any money that is made off that investment each year. Okay, so think about this idea that if we invest $100 in the savings bond over time, each year that 5% will be earned annually, but it's going to be earned in addition to whatever money we gained the previous year, right? So we want to be able to account for the money, the growing amount of money in that savings account each year. That's where compound interest comes into the picture. So compound interest, we have a formula here for. It's future value equals present value, and then in parentheses, 1 plus I, which is interest rate, or rate of interest for the period. And then you can see here we have N, which is number of periods. So the number of years we might be looking to assess. Excuse me. So if we consider our previous savings bond example, again, we just looked at simple interest on that example, but let's say we want to assess compound interest over a 5-year period. So given that information, we already know that this savings bond is going to get 5% interest each year, right? So here's our formula. Future value equals 100, which is the amount we invested. And then we just plug in our numbers here in the parentheses, right? We know that the interest rate is 5%, so that gives us 1.05. And then we have to the 5th degree because a 5-year period, right? So you can see here, if we just go ahead and run our numbers here, we can do this by hand. You could multiply these by hand, or you could plug it in your calculator if you have a scientific calculator. Ultimately, it's going to get us to this number, right? 1.2763. We're going to multiply that times 100. That's going to tell us that after 5 years of having this investment in the bank, we're going to have $127.63. So what we've done essentially is calculate the future value of a dollar using compound interest. And again, we have this handy formula in order to get there. Now that's one way we can do it. Or we could rely on our future value of a dollar table, which is table A1 on page 454 of the appendix in your book. So let me show you what that looks like here real quick. I've just taken an excerpt of the table here, so this isn't the full thing, but you can see the numbers that we need. So this is Appendix A1, Future Value of a Dollar table. And you can see here on the left-hand side of the page we have period, so this is number of years. Then on the top we have percentage, okay? So again, if we go back to our question here regarding the savings bond, we know we're talking about a 5-year period and a 5% savings bond, okay? So let's start with the percentage. We know we're getting 5% interest, so we'll start there. And then we know it's a 5-year period, so we just go down to the 5th year here, and then that gives us the 1.2763. Looks familiar, right? So you can see that the table is essentially a shortcut for us to get to our multiplier here to calculate future value of a dollar. Again, either way will work. Either way will get you to the same number here. And it's important that you understand how the long form process works. But again, in the real world, if you were running calculations like this, you would likely rely on your tables because, again, a lot of the footwork has already been done. It saves you some time. You still get to the correct answer. We can still predict the future value of that savings bond in 5 years. The one thing to note is the amount of work you have is obviously much less, right? So this is the amount of work you would show if you do it longhand. And it's, of course, much more simplified here because all we have to do is multiply that present value times our multiplier, which we got from the table, which, again, gives us the exact same answer. Just looks a little bit different. All right, so here's another practice case for us to look at. So a sport organization invests $10,000 in a savings bond that pays 3% interest annually. So we're going to do the same thing that we did on the last one, right? We want to calculate the future value of that investment after 5 years using compound interest. So again, same formula here. Future value equals present value, then our 1 plus interest to the nth degree, which is the number of years, right? So again, if we want to do it the long form way, we can. We can plug in our numbers in terms of interest rate and number of years. In this case, we're talking about a 3% interest rate over 5 years. So again, that will get us to this multiplier of 1.1593. We multiply that times our present value of 10,000, which is the initial investment. That gives us a future value of 11,593. So that tells us that this $10,000 investment that the sport organization is making is going to be worth $11,593 in 5 years if we account for this interest rate. So again, we can do it using this formula, or we can use our future value of interest table in A1. So let's go back to that one more time. Again, different number in terms of percentage here, right? So our interest rate is 3% instead of 5, so we want to go to the 3% column. We want to go down to the 5th year because we know it's a 5-year period again. Again, that gives us our 1.1593. As we know from doing it in the long form, that's the exact same multiplier we got, right? So all we have to do is plug in that multiplier. We get the exact same answer, right? So again, the idea of using the tables is that we have all of these multipliers already calculated. So it's just a time saver, really. Okay. All right, so that's calculating future value of a dollar. Now, Since we've calculated future value of a single investment or payment, that's useful, but we also have to keep in mind that oftentimes in life and in the sport industry, money isn't always paid out in one lump sum, right? Actually, more likely it's spread out over time. So there are basically two different types of payment formats that are paid over time. The first is an annuity. So an annuity is any series of equal payments or receipts made at regular intervals, okay? So for a sport organization, for example, this could be the monthly mortgage on a facility that they've purchased. This could be retirement contributions to their employee paychecks. This could be contractual payments they have either with a player or with a brand. Again, these are payments, a series of payments that are made over time. Could be monthly, could be yearly. But typically there's some endpoint to an annuity, right? So if it's a player contract, maybe it's a 5-year period of time. If it's a mortgage on a facility, probably more like 20 to 30 years of time. But the idea is there is a starting point and an ending point of an annuity. A perpetuity, on the other hand, is any series of payments that continue indefinitely with no endpoint. So, as you can imagine, annuities are much more common in the sport industry than perpetuities are. Probably one of the few examples of perpetuity in sport is when, let's say, a donor passes away and then leaves their estate to a university athletic department. Maybe they went to school there and they want a scholarship fund created in their name. So if they were really wealthy, they could create an endowment, which is essentially a perpetuity, right? So these payments would continue indefinitely as long as there is money being invested in this account. So that's one of the rare examples of perpetuity in sport. Most of the examples we're going to look at here in this unit are going to be annuities because, again, that is the more likely event that would occur. Okay. So again, we've looked at what it means to calculate the future value of a one-time payment. Now we want to know how to calculate the future value of an annuity, a series of payments over time, not just a single payment, but a series of payments over time. So basically, in order to do that, we need a new formula. So here you can see FVA. So instead of just FV, which we had when we were just looking at future value of a dollar, now we have FVA, which is future value of an annuity. So here we have FVA equals whatever the payment is, so whatever that regular series of payment is, and we're going to multiply that times our multiplier here, which as you can see is a little bit more involved in terms of determining, and we'll look at an example here on the next page. But essentially the information we need to calculate future value of an annuity looks very similar to what we needed to calculate future value of a one-time payment. So we need to know what the payment is. We need to know the interest rate or the predicted interest rate over that period. And then we need to know the number of periods. Okay? Let's go look at an example here. So practice case here, we've got a men's basketball coach who is investing $1,000 a year into an investment account. This investment account earns 6% interest, pretty good interest rate. And he's planning to invest for 4 years, okay? So we have the payment amount, we have the interest rate, and we have the period of time, right? So we have all the information we need to calculate future value of an annuity. Now I'm not going to go over all of this, but you can see that I've plugged in all of our numbers here in order to determine or calculate future value of an annuity. So again, we have the interest rate here, we've got the period of years, and then we've got the interest rate again here, and the amount of payment, okay? So again, you would want to calculate each stage of this formula, and ultimately what we're looking for is to get that multiplier, right? We want to be able to determine what the multiplier is so we can multiply it times our payment, which is $1,000. Well, in this case, we get to the very bottom of our calculations and we see the multiplier is 4.3746. We multiply that times 1,000. And that gives us a future value of this annuity of $4,374.60. Okay, so this investment the coach is making, he's investing $1,000 a year for 6 years, or sorry, for 4 years, gaining that 6% interest. We know the future value of that annuity in 4 years is going to be this amount. So again, this is quite a few steps here, right, to get to our multiplier. Or we could use one of our tables. So in this case, since we're calculating future value of an annuity, we want to look at table A2 in the textbook. Okay, so if we go to table A2, and I apologize, it's kind of blurry here on my screen, but if we go to table A2 in the back of your book, in this case, again, we're talking about a 6% interest rate, right? And it was a 4-year investment. So if we go down here to the 4-year column, gives us a multiplier of 4.3746. Oops, looks familiar, huh? So we can get that multiplier in a much quicker fashion than running this full formula, right? We still have to multiply it times 1,000. So again, if we just use the table, if we didn't use the full formula, it would be 1,000 times 4.3746. And again, we get the exact same answer that we got doing it the long form way. We just saved quite a bit of time, right? So ultimately, when you are given one of these scenarios, say as a practice case or on a test, feel free to use those tables. That's what they're there for, is to simplify this process. Again, I think it's important that you understand the formula and how it works, but I'm not going to ask you to run this full formula when you're given the scenario on the test, because again, we can get the same answer by using the tables. Okay, so I'm going to pause there. So we just covered future value of a dollar and future value of an annuity. The next series or the next video lecture is going to look at present value of a dollar and present value of an annuity.